All right, class, got to talk about functions today. We got degrees, we got descending order, we got polynomial functions, we got type, we got classifying them. It's happening. We're going to do descending order first. We're going to do that first. Descending order is all about the exponents. So if you have x to the fifth, x to the fourth, x to the third, it starts with the largest power and takes its way down. Fifth power, fourth power, third power. X squared, x, some number like 12. As long as the exponents are in order, descending order, you got it. Fifth power, fourth power, third power, all the way down. So if you have a function right here, this one is not in order. You need to put it into order. So if we redo this, third power, fourth power, first power, eighth power is the largest, he goes first. Fourth is next, then third power, then first power. 8, 4, 3, understood 1. So putting them in order of the exponents is called descending order. So it's a big deal. Get them in order, get organized. All right, 1, a 2, a 3. Let me give you another one. So let's put in some coefficients this time. So it doesn't matter how crazy the coefficients are. Like here's a 17, a -3, a fraction. Don't let those throw you off. Don't see 17 and think, oh, he's the biggest, he must be first. You've got to look at the exponents. First power, sixth power, fifth power. So for us to put this in descending order, sixth power is first. So -3, x to the sixth, plus 1/2 x to the fifth, plus 17x. That is the correct descending order. So don't let the coefficients fool you, stick with the powers. All right, descending order. I think we got this. All right. So there's a couple examples there. 1, 2, 3, 4. Okay, let's do the next thing. 1, 2, 3, 4. Let's do leading coefficient. So we'll practice our order some more, and now we'll practice leading coefficient. Okay, so you get asked this on the assignment, like find the leading coefficient. So first off, grab this function, put it in order, descending order. Look at your powers, fifth power's biggest. And 6 out here doesn't have an x. It doesn't have a variable with it. So he's automatically last. So if it's just a number with no letter, he's last place. All right, here we go. We've got -10, we've got 4/7, we've got 9, -6. So it's in descending order. The next thing you're asked to find is what's called the leading coefficient. So on your assignment, they'll say, hey, find the leading coefficient. Put them in order. All right, they're in order. Fifth power, he's the biggest. Its coefficient is this -10. So the leading coefficient for the whole function, -10. So not that bad. As long as you can get in the correct order, boom, you've got this. One more of those. I think that was 4. Here's 5. F of x is equal to, let's put in more crazy stuff. 8x minus square root of 5, x cubed plus 2 minus 6x squared. So here's a polynomial function with a bunch of crazy stuff going on. We look at this and you say, hold on, Mr. Porter, I got to put this in descending order. I got to get it organized. So third power, he's going to be first. Second power, first power, and then a number on the end, and I'm set. Once you have it in descending order, that's your biggest power. Whatever's in front here, this is your leading coefficient. And even if it's crazy, like a negative and a square root of 5, you put negative square root of 5. So finding the leading coefficient, just put them in order, get this guy out in front. That's what you're looking for. All right, number 6. Oh, okay, this is going to get big. Okay, type of function. Type of function. Here we go. Okay. So we've got a function, f of x, let's just say is equal to a number. If it's just a number, you have no variable right there, just like f of x equals 8. The type on this, let me get this out of the way. This is what's called a constant function. So you get this on the assignment where they give you a function and you've got to say what type is it. That's a constant. Let's say we've got standard linear one here. How about like 4x plus 7? Here is your largest power of x is x to the first. So this is what's called a linear function. Let's do x squared. So let's say we had x squared plus 8x plus 15. So my largest power is squared. When that's the case, we already know this. This is quadratic. We've done a bunch of quadratic stuff, quadratic formula. Let's do one more. How about third power? Like x to the third minus x squared plus 7x minus 4. So in descending order, third power is the largest power. When that's the case, this is what's called a cubic. And let's throw one more at you right here. So f of x is equal x to the fourth plus 2x cubed minus x minus 6. Okay, so one more. It's in descending order. Here's my largest power is a 4. When that happens, the largest power is a 4. This gets labeled as a quartic. Okay, so let's go back through it one more time. If it's just no letter at all, it's just a number, that's called a constant function. Largest power is x to the first, linear. Largest power, x to the second, quadratic. A third power gets it called a cubic. And the largest power, fourth power, called a quartic. So you get functions given to you today, and then you've got to label what type it is. Oh yeah. So we've got to come up, is it constant, linear, quadratic, cubic, quartic? That's our job on a lot of these. All right, and while we're at it, I'm going to show you how to find the degree of the function. Let's do this. Let's put degree right here, right next to the type. So this is going to be good. So whenever you put your function in descending order, whatever your largest power is, in this case fourth power, whatever the largest power is, that's your degree. So if it's fourth power, my degree is 4. Here's first power, here's second power, here's third power, but my largest power is a 3, so the degree of the function is a 3. Like on a quadratic, here's first power, second power. Largest power is second power, it's a 2. Largest one for linear, you only have one, x to the first, so it's degree 1. Here you don't have any x at all. When that happens, this is kind of a trick one, it's just 0. So again, when you're trying to find degree, look at the largest power you have for your function. Like on this one, the largest power is a 3, so that makes it degree 3. So today you've got to find what type it is and label it as quadratic. Also, you have to find what degree it is for each function. So let's see here. Let's say we had like 17x to the third minus x to the fourth plus the square root of 8 plus 10x. So let's say we have this function for number 7. So first thing you do is you're going to change the order up. We'll rewrite this guy. So descending order. Negative x to the fourth is going to be first. Then x cubed. Then x. Then a guy with no x. So you got a couple things you're going to have to label. You're going to have to come up with type and degree of the function. So the largest power is a 4, fourth power. So if it's fourth power, you get this cool word called quartic, and that means the degree is 4. So find the type, find the degree. I think that's not too bad. So that was number 7. Let's do 8. All right. What do we got here? Square root of 3 minus 12x plus 5x squared. So when you get this problem, you're going to put it in descending order. He's first, 5x squared minus 12x plus square root of 3. So you reorganize it, you get it in order, and then you can figure out, well, what type do I have? What degree of the function do I have? Well, the largest power is squared, second power. If that's the case, then this is a quadratic, and the degree is the largest exponent power. The degree of this function is 2. So find the type, find the degree. Find the type, find the degree. Let's do one more of those. Okay, so we get this function, and of course the order's all crazy, the crazy order. So reorganize, get it in descending order. 9x cubed is first, 1/4 x squared, whoops, minus 13x plus 7. So no matter how crazy it looks, reorganize it, put it in descending order. And we can name the type, we can name the degree. So largest power is third power. If the third power is the largest power, its type is called a cubic, and then the degree is based off the largest power. If this is third power is the largest, you put degree of 3. So find the type, find the degree for each function. Okay, for this home stretch, we've got to decide there's some crazy stuff that makes it not a function. So you've got to, I think, determine, so is it a polynomial function? Or is it not a polynomial function? Okay, so for these last three examples, you got two choices. Is it a function? Is it not a function? So that's what we're trying to decide. I think we're all the way to number 11. So let me give you a couple looks of what makes it not a function. Like this is not happening. All right, here we go. So let's say you had x cubed minus x squared plus 6x plus 9. Looks pretty normal, but what if I come in right here, instead of a first, I do a negative exponent. So if my x has a negative exponent, like I'm looking right at it, there's a negative exponent. Anytime that shows up, that guarantees this is going to be not a polynomial function. So, is it a polynomial function? No. What makes it not a function? Negative exponent. So if you see that, automatically like, nope, not happening. Another one that disqualifies it, let's do number 12, is if your x is on bottom. I got one like that? Sure. So here's 15 minus x cubed plus 7 over x plus x squared. So when you walk up to this one, what disqualifies this as a function is an x on the bottom of a fraction. So if your x shows up in the denominator, then there is no way this is going to be a function. So just like, nope, not today. All right, I got one more left where I can kind of show you the difference on these fractions. Hold on. All right, I got people knocking on my door. We're just going to call that good. There you go.